Good afternoon, Austin. It's really a big pleasure for me to come to the city where there is a Magento office and give some insights about my recent researches. So let me speak a little bit about myself. So I was one of the lucky former members of Magento 1 core team. I don't work anymore in Magento. I'm not any Magento employee. Another thing, I love to optimize performance, and this is like one of my favorite things to do. Also, I give trainings, and I'm an independent consultant, so if there is some kind of performance issue or something like this, customers usually contacting me and ask me what we can do with it. So, we are going to talk now about the evolution of PHP applications. This talk in general is going to be for PHP developers, with a small piece about Magento to an end. So make sure that you stay till the end of the talk. So it's all started, right, a long time ago with mod PHP. So we had good old mod PHP where every server thread was starting a new PHP process, and then application was bootstrapped, and then the application was executing the business logic. So it was a little bit inefficient. There was some drawbacks, of course. So first of all, the dynamic server processes was not limited. So it means every Apache process that touches a PHP file was starting a new PHP process. Another thing, the process of the PHP process itself was alive unless the last byte was delivered to the customer by Apache. So there was no separation of PHP process and Apache itself. So it's like integrated part of the Apache server. And every new PHP process itself was taking some time to start. So it was not something that was already pre-warmed, and it was just processing the PHP code. So there was still time needed for loading all the PHP configuration, starting up different extensions and so on. So, is anyone still running mod PHP in production? Okay, it's good to see that there is no hands raising. So, then there started the era of PHP FPM. It really revolutionized the PHP application world. First of all, we got a server thread that was waiting for FPM, so Fast CGI Process Manager, to pick up a connection, execute some PHP script, and return back the content of this PHP script execution. So the FPM was taking the process pool, or was starting a new process in the pool itself. Then the application was bootstrapped, the business logic was executed, and the page finally got rendered. This is quite interesting approach. So we didn't spend any more time on rendering. We didn't spend any more time on starting up a new PHP process, and also we were really not spawning unlimited number of PHP processes. We were waiting till there will be an available spot to execute our application. So this is more controllable structure. This is more memory efficient structure and CPU efficient structure itself. So we didn't spend too much time to execute our PHP code. But there is a little bit of a drawback, because if our PHP process was giving some memory leaks, every consequent PHP process was still using the same amount of memory, unless you restart this particular PHP process that was running it. Now, however, there is a very interesting thing happening in the PHP community in general. The new era of asynchronous I/O started in PHP apps. And this is kind of new black. This is so amazing. So how it looks like. First of all, we don't have any more PHP FPM as a service itself. We have our PHP application being a server. So this is a little bit different thing. Over here we have a server thread that is directly connects to our application master process. So our application master process receives information from Apache or Nginx that, okay, we want to process something. Then our application master process executes some business logic and returns back the output to a customer browser. So it means there is no time spent on bootstrapping our application. The only time that is spent by our PHP application is actually executing business logic. The drawbacks, there are quite a lot of them, right? You have to control the used memory, and you have to maintain the garbage collection and everything around it. Another thing, you have to ensure that you are using asynchronous I/O operations, so you do not execute file get contents or MySQL query or anything like this in synchronous mode, because as soon as you have one PHP process that processes this kind of stuff, it means all the rest of clients that are trying to connect to your server are actually have to wait. Executing it in a synchronous way, it means you have to spawn a children process or delegate it to another service in order to execute expensive operation, and your PHP process itself still will accept other customers, other clients that try to connect to it. Another thing is, if a single line of code fails in your PHP process, it means the whole app will fail. So, the question, is it possible with Magento 2? Anyone? Maybe someone will raise a hand, or? No? Actually, it's impossible to implement it in Magento 2 as a whole application, because we have so many business logic, we have so many modules that are affecting each other. And if we introduce something like loading of the quota in one thread, and then another thread will load another object, and then we have a lot of memory being used and not cleaned up, and no other processes are cleaning it up. And imagine maintaining this kind of application, yeah, it would be a nightmare. So it's much more easier to have kind of fast-running process that just finishes execution and that's all. But there is a good option for it. It's called microservices. So what is a microservice? Microservice, it is a component that runs a separate application. So like it's a very small piece of your software that executes one small thing and executes it well and in a scalable way. So what can we do as microservices in Magento? First of all, that came to my mind, this is sessions. And why sessions are a good candidate for it? First of all, every page request starts an I/O operation to retrieve the session data for this current customer, right? So we have to connect to Redis, to Memcache, to whatever, in order to receive the current session data. So if we, let's say, have a master process that keeps it all in internal PHP array, we don't need to establish any other connections except like to connect to this master process, right? Dynamic requests, for instance in Varnish, will bootstrap the full application. But if we run a separate, simple, lightweight session application that will share some part of this session data by responding to your browser request, it means we don't need to bootstrap the full application, we have only small business logic being executed, right? So here is an example of how we can implement a microservice for a session application. So let's say we have a server startup phase, we just start up our server application, and then if we receive any connection, we are doing the lazy load operation. The lazy load operation means like we will connect to Redis or whatever, where we store our session data, and then we keep the session data in our PHP memory. We do not do any other I/O operations. Then, let's say, we execute every 5 seconds a special process that will garbage collect the sessions that were not active for more than 5 minutes. In this case, we can control our memory footprint, right? And by doing this garbage collecting, we can save our session data to a slow I/O system like Redis or Memcache or anything like that. And when we stop a session server, we also persist this data to some kind of Redis storage. So this is quite a simple example how can we use microservice, but this is not the most interesting one from this presentation. Another one, as a candidate, is stock processing. So now imagine you're running a store that needs to handle a large campaign during holiday season, like during Black Friday or something like this, and you have hundreds of thousands of customers that want to buy some product, and you need to execute on every page request, you need to execute a database query to check is this product available for stock or not to buy, right? So also every order place request requires a database log and stock table, because we cannot be sure is this product still in stock or not. So it means we are not having enough of availability of our system to process multiple customers that are connecting to buy the same product. So we usually have to sacrifice our stock integrity for performance reasons when we are doing this kind of sales season, right? But what if we create a stock application and we run it as microservice that is responsible for deducting the stock data in memory, in PHP memory, right? We don't need to do any database logs. We are just synchronizing our stock data asynchronously without even having our customers knowing about it. I just want to show you some live proof of concept. I just created a simple PHP application that is written in React.js that deducts a counter on every page request. And I just want to show you how much requests it can process per second. So let me just switch. So we have our React server over here. I'm going to start it up. It's called test.php. It started, the server is running at this address. We can access it in my browser right away. Wait a second, here it is. Okay, here it is. So I will start up a new session with a new window. So here it is. It tells that the current counter value is 100,000, right? Now I'm going to run in another thread. I'm going to run an A/B test. So I'm going to execute in 4 concurrent connections. I'm going to execute 5,000 requests to our special route in this server called deck. It means it will decrease the value. I'm executing it. Bam, bam, it's done. And now let's take a look what is the average response time from our server to execute this 5,000 requests. The response time, this is not in seconds, it's in milliseconds. So it means it's 0.2 milliseconds to execute a single stock decrease process, right? That sounds fine, but let's see, do we have a stock integrity in this case? So let's open it up. Here I have another node, it's called info, that outputs a little bit more information. So here we have that we have processed 5,003 requests, and our stock counter value is at 95,000. So it means it correctly deducted 5,000, and there is no order lost, right? And what is the memory footprint of our application? This is around 1 megabyte. Isn't it cool, right? So let me go back to my slides. Another candidate, unfortunately I don't have a demo for it, but it's a little bit more complex one, just for you to think about it, just about possibility of such a thing. So quotes and shopping carts. We know that we have to persist on every change in a shopping cart, we have to persist this data into database, right? So we have to execute a write operation to our database server. And it means, yeah, in regular way, we cannot scale this operation that easily. So we could create a quote application that will store quotes in memories that are currently running, right? And we can also run some DB synchronization, let's say once a minute, once 5 minutes, or something like this. We also can execute some business intelligence over there on those quotes. So we have all these quotes in memory, and based on particular customer behavior, we can analyze, maybe we can suggest something for this customer. So we can create totally separate applications within Magento. And what is cool about this, that this is all in PHP. It means we can reuse Magento existing components in order to create this kind of logic. We don't need to write it in Erlang or Haskell or Scala. We have everything at our hand. The only thing we need to change a little bit our attitude to the way how we operate with PHP. PHP is not something that limits you to create high available applications. As soon as you try to implement something, it's possible. The only thing you need is the idea. So another candidate is image resize processes. So we know like every category page, product page in Magento has to resize images in order to deliver this content to the customer in the best way. And if, for instance, we have responsive website, right? We have to generate images for every kind of device in the best pixel ratio in order to deliver small images, but for Retina displays, we might deliver a bigger one. For just regular Android phones, we have to deliver smaller ones in order to save the bandwidth. So it means we have to render something like 5 images per product in category page, and if we show hundreds of products, it means it will result in 500 images to be resized on the first call. It's a little bit of performance drawback, and all these operations are happening sequentially. We cannot do it in parallel. So what we can create, right? We can create an image microservice. So we can create a separate app that will receive requests. Okay, please resize for me this image in this size. We just send this request. We don't wait for response yet. We continue rendering the next product in the list. We send another request, another request, and another request. And all those images then will be just resized in parallel. And in the end of the rendering of the page, you just can wait till all the images are ready if you are want to be sure that all the images will be resized already when customer visits the HTTP server in order to hit this image URL. So you can execute some wait process in order to wait for this asynchronous operations to finish, right? And all this can be done in parallel. And if you have 64 CPUs, it means you can resize 64 images at the same time. We don't need to wait till all those 500 images will be resized, right? So main application can utilize asynchronous I/O in this case even. So we can render anything and we can just wait till the operation will get finished if we don't need immediate feedback like data or something like this. So if you want to learn more about asynchronous PHP, here is some links you can visit. First of all, the React PHP. This is a framework that allows you to create asynchronous PHP applications easily. We have also PHP Fast CGI. This is kind of interesting project that implements the Fast CGI server in PHP application itself. So you can start your PHP application as Fast CGI server and point your Nginx or Apache to your application Fast CGI server. With React PHP, it's a little bit different because you have bare minimum HTTP server or either TCP server that you can use for other processes. But with Fast CGI, you can easily integrate it with your existing solution. Also with React PHP as well, but it's a little bit of overhead to build HTTP query. So here is also a link to a simple counter service, right? This is the one that I was presenting. And if you have some questions, you can ask them now. Otherwise, you can ping me on Twitter. send me an email, whatever. And during the after party today, if you want to learn more about asynchronous PHP or other performance optimizations tactics, you can find me and talk to me.